In this talk, we try to share some of the insights in why and how we felt like we optimized our workflow. It's not going to be too technical, so it's, if you're really interested into the details and how we implemented it, just meet us afterwards and we can show you all the codes and share it with you. So there's not too many secrets in there. OK, just briefly to start out. So we are a 4-person indie company from Vienna, Austria. We're a fairly new company. So the company started about 2 years ago, and we're working on a first real game production title. And I'll briefly show you a trailer so that you can see how it looks like. Thank you.
Thank you.
So it's a racing game. You can fly pretty much everywhere. You can hop around and snap around the environments. And it's going to be out on PlayStation and Xbox sometime later this year. So our path so far, it's in production for 2 years. And we had some experience. So it's just a 4-person team. It's 2 artists, 2 engineers. So we are the engineers. We had some experience with Unity before, but not on this scale, so we did a couple smaller projects. And especially me, I haven't really worked with Unity before. So in these 2 years, I pretty much started with Unity. I have a background in computer science and computer graphics, so I had some prior knowledge, but I haven't really used Unity so far. So for us, it was kind of all the learning by doing, and kind of as we went, we tried to build our tools to suit our purposes and to really optimize our workflow, because it's just 4 of us. Brief overview. First, I'm going to start out with giving you a bit of background about what we think is optimization and why we did the stuff. Then we're going to talk about, or Matthias is going to talk about our Maya importer pipeline. So we have a custom importer where we can import scenes from Maya and export them back to Maya. We have our own static batching solution. We have our own build pipeline. And there's a couple other small tools, and there's a bonus stage as well. So just to get a brief overview, who of you in the audience are programmers? OK, that's pretty much the majority. And artists, tech artists? OK, also a couple of those. OK, perfect. OK, so as I said, it was pretty much a learning by doing approach for us. We just did it as we went. It was pretty much a greedy approach. Whenever we needed something, we typed it into Google, and we copy-pasted whatever came up. And it worked surprisingly well for editor scripting and to get all the buttons and the GUI stuff, because the editor GUI API can be a bit overwhelming in the beginning. But it's very quick to just throw something together, and somehow it works. It doesn't look pretty, but it does the job. Another thing is that since it was our first project, we didn't really know what we were looking for when we built the tools. That also means that we didn't really use anything off the asset store. Probably there's a lot of build tools. There's a lot of, pretty much, I guess, all of the tools that we build you can find in some way or the other on the asset store, and probably also better in better quality. But for us, part of the process was to find out what it actually was that we wanted to have. So for instance, the build pipeline, it was an ongoing development, and it evolved over, I don't know, 1.5 years. And it changed and transformed so much. So that's why we did the things just as they happened. Didn't really spend much time looking for stuff because we had no idea what we were looking for. Coming to optimization, there's kind of a few obvious truths and obviousness. So global optimization is hard. It's very hard to optimize something for every condition, every constraint, everything. So if you want to write the perfect build pipeline that suits everybody and works miraculously for everything and is super fast and super easy to use and super integrated, that's a very hard job. And yeah, but the easier part is to optimize it for some specific uses and some specific purposes. To really see what you are needing and then go towards that direction and really to focus on what you actually needs. So that special purpose is always easier than general purpose. And yeah, as I said, you have to optimize for your specific context, specific constraints, because there's not always, also that the goals are, can be quite differently between projects. For us, the main optimization goals in tools and pipelines and pretty much in everything that we do, the most important one is reproducibility and repeatability. As you can see, the last item on the slide is time. So time is kind of the least important factor for us to optimize stuff. It is very rarely that we say, oh yeah, we have to write a tool just to make it faster, because to be honest, when you're writing tools, it might be the case that just doing it by hand a couple of times is in total quicker than just writing whatever tool to optimize it. But whenever you're writing a tool, you get kind of added benefits. There's a few extras that you also get, and this is kind of why we did all the tools. So the first was, as that reproducibility. For instance, for our build pipeline, it was very important for us to just press a button, and the build that comes out is the same all the time. There's no configuration errors. There's no nothing. You did something wrong. You forgot about something. If you have to have good tools, then this is something that you can minimize as much as possible. Stability goes in a similar direction. You don't want to have kind of long things that you really have to remember all the stuff. And then there's also efficiency. So it goes a bit towards the direction of time. But we as humans, so it is very tedious if you have to, even though you're quicker, if you have to spend a day, I don't know, creating builds, because it is incredibly boring, it is incredibly error-prone. So efficiency goes in the direction of making us as developers more happy. If we can optimize tedious tasks away from us, then that's also a very good benefit. Reduce human interaction error. As we try to, through the build pipelines, we manifest our process, and we try to reduce error that way. And in the end, making better faster. That's also going a bit towards the time direction, kind of creating more or allowing us to push the envelope in what we do, because we don't have to focus on, I don't know, creating builds, but we can spend our time somewhere else. In that direction, very important part for us also on the game side is separating logic from data. So all the data and configuration part. We tried as much as we could to pull all the data into scriptable objects or into our own custom file formats. And this scriptable object, you can turn them into assets, and you can have them in your Git repository. And you just create the data and the configuration once, and you just reuse the configuration, and it makes things much easier. And of course, it also reduces human intervention error, because you don't have to type in anything. You just, if I want to make a build for Matthias, I just use the data file that I have on Matthias and say, well, I want to build for him. I want to build it for PC, and it should be release build, and I have all the data already entered in the system in the background, and it just spits out the build. It saves a lot of time when you're doing it repeatedly, and it also makes sure that you're doing the right thing. So you don't have to, when you're doing builds, you don't have to worry, well, did I check all the right boxes? Did I enter all the correct data? Because you did it last time, chances are the data is still correct, and yeah, it makes you better sleep at night better. Okay, I'll hand over to Matthias now.
Okay, so let's start with our first tool, which is the Maya importer and exporter. And before we're gonna talk about how it works and what it is, I guess it's a good idea to ask yourselves, why would you do that? Why would you actually build your own exporter and importer into, from Maya and to Maya? Because you can just export your models and then model the scene or build the scene in Unity. But our artists, both of them weren't really in-game developers, so they were used to making rendering scenes. They were working a long time in classic rendering, so they were very much used to Maya. And they wanted to stay in Maya, and they had already had a big host of tools in Maya, which they built themselves. They had a repository in there. They had their own versioning in there. So they wanted to continue to use that. But on the other hand, if you manage everything in Maya and then just export the whole level, how do you do this? How do you get a whole level into the game? Because our game is handcrafted, so there is nothing auto-generated or anything, so all the environments and tracks are handcrafted. So it's always a huge scene you have to transfer back and forth, and how do you do this? So what we ended up with is you have a big scene, and you just export small objects as FBX and transfer also the position data in a separate file. That's the target. That's what we designed as what we want to have. What's important for us then is, especially in the beginning, it's a flying racing game. We had no idea how track's gonna look like, because this is a quite new game genre. There is nothing like a needle curve or something like that. So we didn't know how our track's gonna look like in the end. So we had to experiment a lot, especially in the blockout phase. We had to try out many things. So we had to go, it was not a good idea to only work in Maya, just to move objects around in Maya, export it to Unity, start a build, try to build. Oh my God, this block is a few millimeters too much to the left, go back to Maya, move the block, and so on. So we wanted to change actually the track itself, also in Unity. So we allowed to go also back from Unity to Maya. And this was what was important for us, to keep up this loop, that we always can switch back and forth between them. This was the rationale behind why we did it mostly. The other part was to split it up into smaller files, because we're using Git for the game itself. But as you might know, if you're working on one scene and one track is one scene, it gets hard for the artists if they're working together, that you always block yourselves. I have to move that block, but someone else is working on the same area in the track. How do you do this? And by having the split between Maya and Unity, you actually have a bigger diversion between the files, so it's easier to work at the same time on the same thing. That also helped us a lot in the workflow between the artists. Okay. And they, so since the files are very big, it's Maya files. I never had actually to handle them myself, but I know that it was impossible for us to just drop them into Git. And so they have their own file-based repository, which they actually built themselves over the years. And it's just stored on our local network drive. And they can do that, and just the exported files land really in our Git. That's a very relevant thing for us. So yeah, as soon as we understood where we wanted to go with this, we built a very simple first version. And it looks on the in the game roughly like that you just in Maya you build the scene, you do whatever you want. This is our last track, and as you can see, every object gets automatically an ID assigned, and that ID stays forever. So if you change the hierarchy and you move objects around crazily in the hierarchy, all that survives the round trip. And this is done simply through a big JSON file where just all the objects in there, which also stores the hierarchy and all these IDs that are connected between. Okay. Yeah, what's also important that that all the settings what should be in the Unity scene in the end, you configure that in Maya, because they had to use a lot of meta objects to build the whole scene, so they are modeling and doing everything in the main scene, and not everything they have in Maya they want also have in Unity. So they can select, deselect, and change everything in Maya what should end up in Unity. What's also important that they needed over the time, they realized, okay, how do we handle materials? They want to, because since they are doing the whole UV setup, they needed the textures already in Maya, where they did the UVs. So we somehow had to get what material will be on the object and what textures will be on the object also in Maya already. So that was a little bit of a hack, since Maya, as far as I understood, doesn't really support the concept of different material types. So we abused the whole things like Blinn and Phong and so on, and converted that to our own types of shaders. So it was weird settings that we used in Maya that looked quite strange sometimes in Maya, but it made sense for us that we just made a transformation. Okay, whenever there is a Phong shader in Maya, it's gonna turn up as a UV animation thing in Unity. So that's what we came up with an idea. Another part, we had objects in there which were Unity objects, which had logic on them, which had scripts on them, like moving objects that go around, that are triggered by the user. Those are set up in Unity, but they survive the round trip. So you can add all the scripts in Unity, save them, and then that part gets exported to Maya as well. Maya stores them, but ignores them. So when you go back to Unity, it's still there, all the data is there, but it gets ignored by Maya. So you can't edit them, but it survives it. That was important. We learned that over time. That is a really important part. Yeah, and in the end, when you import it into Unity, it automatically does static batching, but Simon will talk a little bit more about that, what it does and why it does. We learned that we shouldn't have everything in our custom scene files, because that would bloat it up and make it really confusing. So sometimes we just hacked around it, and that actually, it's what Simon said. When you try to build a perfect exporter and importer that does everything, you will spend a lot of time. So we sometimes just ignore data, so that we don't care. We just remove it, and it's going to survive. And if it breaks, we're going to fix it and add it. But we didn't start by doing everything. We only added features when we needed them. The specific material parameters we set in Unity. So we got texture on what kind of material will be on the object. But really the colors, the glow colors, the reflectivity and all that stuff, we actually set just in Unity. And that's actually it. So I give back to Simon.
Thank you very much. The build pipeline also, the import-exporter pipeline also allows us to add additional stages, kind of to post-process it and to do other stuff with it. So some things like wiring up level objects, so specifically tagged objects, putting them on layers or taking them from layers and doing stuff with attaching all the scripts and so on. And another thing is static batching. Static batching, or batching in general, since we're going also to consoles, is very important for us to keep the number of draw calls down. From the very beginning, we set up the game and the art style in a way that we have, it fit together naturally, that we have fairly low poly count. So we knew from the beginning that it was possible to batch together stuff quite easily. We tried to have as few materials as possible. You only have a handful of textures, and really the magic comes from Raimund, our artist, who really creates the UV layer that gives it a very distinctive look. And all that made kind of static batching possible for us. But the thing was, so there's a static batching option in Unity. You can also have dynamic batching. And we flipped the switch, and it didn't really move the needle much. So nothing much happened. Performance didn't really go up. Draw calls didn't really go down. And to be honest, we never really found out why. So yeah, you just flip the switch, and you can try to observe it in the frame debugger to see how the batches are drawn. But it never really made much sense for us because it was seeming that stuff was batched together pretty randomly. And we also wanted to have a bit more control over it. So does it make sense for us to do static batching even though Unity does static batching? So why not use Unity static batching? And well, specific problems usually require specific solutions. So there's the no free lunch principle. That means if you're trying to optimize for a general, or let me put it differently, when you add information to solution, it can be better than a more generic solution. Because for us, we knew how the camera would move, we knew how the level was structured, so we could add in more information into our batching system. We could just manually batch stuff together that kind of belongs together. So does it make sense to always go that route? Well, it depends. If you're really going for a specific solution, then it's probably the way to go. If you're trying to come up with the next best super batching solution or whatever general purpose thing, you're probably not going to beat Unity at their game. I guess they're pretty good in doing the general purpose things, or for instance, shadow mapping and so on. So there's a few general purpose systems in Unity that work quite well, but that you might have to replace at some point for very specific solutions and very specific things, because Unity never could estimate or anticipate how we gonna need batching. You could do first-person shooter, you can do top-down, you can do whatever. So all these specific problems require very specific solutions. So we batch meshes together that kind of belong together. It's mostly based on location, based on where they are in the environment, where they are in the tracks, and so on. We do that, or the artists do that in Maya. So we have the scene graph, and they pretty much they annotate subtrees. So you can pretty much put an annotation on a subtree, and it says, okay, batch all those in the subtree into individual meshes. It all happens after the import. So when we import or refresh the level, it is imported, previous batches are released, and then the new batches are created. And the creating of the batches is fairly simple. So we have to sort them by material, because only meshes that have the same material can go into a batch. And we just in code create new meshes, and we store the meshes as asset files on a disk. And we just deactivate the old meshes, so we still have them as reference in the scene, and we still use them for physics and so on. But we just add the new meshes to it, and they also have a little annotation, so that makes it a bit manageable for us. Limitations are, so one of the limitations is, since it is kind of a static process, we have a lot of new files coming in. So whenever you do something, it can make many meshes change. And working with Git, it might be an issue at some point, and it's not that convenient. You do a re-import, and kind of all your meshes changes, or all the meta files change because the meshes have changed and so on. So it can be a bit messy, but it works to some degree. Another drawback is we're using the Enlightened real-time GI system. And the thing is that all meshes that are batched together have to have the same GI settings, because in Unity you can only set the GI settings per mesh renderer. and thus we have to make sure that they all have the same setting. Practically, that's not that much of an issue. There's only a couple of instances in the game where we need a bit higher resolution from the GI system, but where we still want to try to bake different meshes together. So there's kind of, we increased the batch count with about, I don't know, a few meshes. Probably we have 5 more meshes now because we needed a few extra meshes for higher GI resolutions and so on. So that's a quite manageable limitation. What's a bit bigger though is the 16-bit short int limit for vertex indices. That's quite a technical thing. In Unity, if you create a mesh, the mesh can only hold, I don't know, something like 32,000 or 35,000 vertices, because the index array only uses short ints. So you cannot address any more vertices. And roughly 30,000 vertices per mesh, that's not very much. It works for us pretty okay, because our meshes are very low resolution to start with. But for instance, larger chunks of the environment, it would be nice to have just larger batches. There are some ways where how you could get around it. You could do rendering from compute buffers, just kind of drop everything into compute buffer, then you don't have the limitation. So you might have to see if this really is a limitation for you and ways to get around. And probably at some point, the 16-bit limit will go away in Unity because it seems to be a bit a thing from the past. We also created a few small helpers for it. On the left side, you see our own custom mesh inspector that we have. So whenever you select a tree in our scene, it lists all the meshes in that tree. And in this case, you can see that in that particular subtree, there's a total of 5 different materials. And for each material, you see how many meshes are with that material. And then below that, you have a list with all the mesh filters and all the meshes attached to it. And for us working with it, the most important is the vertex count, because you always have to kind of keep track of how many meshes are you combining just to stay below the vertex count limit. Otherwise, when you try to batches, you get weird error messages. And on the right hand, since we had an issue with the global illumination settings, we have a little tool that shows us inconsistency in light maps. So it goes through the scene, and for every batched subtree, it takes a look at the meshes and just checks if the light map settings are different in the meshes. So that then we can select the mesh and correct it. So using those tools, we kind of found a few instances where our settings were off. Stuff that we would not have noticed otherwise, but just through those tools, it worked quite okay. Yeah, so that's pretty much the static batching tool. And now we'll go to the build pipeline. I guess the build pipeline is probably one of the first tools that we wrote very early in the project. And the initial motivation for us was a bit weird. So we had the real-time GI system, and when you have a scene open in the editor, and you have auto-bake on, it automatically will bake or pre-compute the real-time GI data. We have Synology NAS in our office, and we have a network shared GI cache that's on the NAS. So the practical workflow is that somebody has the scene open, somebody pre-computes it, and whoever then later, after the pre-compute, opens the scene, will just pull in all the data from the cache and has a GI solution to work with. The thing was, it only works when you have the scene open in the editor. So when our artists, I don't know, made a mesh update, just updating a single mesh, an FBX that was in 3 tracks, we had 3 tracks where the GI solution wasn't validated and had to be recomputed. So how do we do that? Just opening every scene in the editor, waiting for it to run through, and then opening next scene is very tedious. And the quickest way that we found out was, well, we just trigger build, because whenever you do build, it also computes the GI solution. So yeah, that was kind of the starting point for us for our build pipeline, that we wanted to have a way to easily compute the GI cache overnight. And kind of then a few more and more features have been added. We added level configs, build config sensors, but I'll show it to you in more detail. So the goals evolved over time, of course, and these are kind of the goals as we have them right now. As I said in the beginning, repeatable and reliable is the most important part. We're currently going through console certification, and just pushing a button and knowing that the correct build will come out the other end is very important. So I can just push the button, go home, and I know the next morning I have a build where with all the right switches flipped and so on, and I don't have to worry about configuration and so on. It just makes life much easier, and yeah. You have so many other things to do, and you don't want to worry about your build. That's the point. It is data-driven, because we want to create multiple different builds at once. One of the things that we have is, that we had also very early on, was build personalization. So whenever we were handing out a build, we made a build specifically for that person. So when I was making a build for Matthias, and I would enter Matthias' data into the build system, and I will spit out a build that, whenever you started, it said, "Hello, Matthias, thank you for playing." And it would have a little watermark below it that said that this was a build for Matthias, and so on. It adds a nice touch when you're giving it to press, kind of showing you that you really made a build for them, or when you're giving it to partners or to friends, and so on. And it also adds a bit of accountability, because whenever you're handing out builds, you don't really know where they're going to end up. So, I mean, it's probably fairly easy to remove the watermark if you really want to, but yeah, just put the name tag on, and then you can. It's more easy for you to track your builds. And another goal that we have is add additional steps to the build pipeline, but we'll see that in a minute. So that the full build for us takes, very much depending on how good the cache is currently, somewhere between 10 minutes and 3 hours, roughly. So if we really have to recompute all of the GI solutions, it's about 3 hours. If we don't, it's just 10 minutes. So if we're doing multiple builds, the first one might take a bit longer, but the consecutive builds, they are much quicker. It is all data-driven, so we use a ton of scriptable objects in pretty much everywhere. And scriptable objects have been something that we discovered very late in the project. So, yeah, being new to Unity, those are the things that you learn that, there's scriptable objects. You can do many awesome things with them. And yeah, so use scriptable objects. They're awesome. And we have a hierarchy of config files. So we have global settings. Global settings are kind of the version. And then we have the personalization data, where I can make a build specifically for Matthias. And then I can have certain build types, release build on PlayStation, release build on PC, and so on, whatever. That's kind of the stuff that we use. And another thing is the track list. So it's not only build configuration, but it also ties in game configuration. So we can make, through our build system, we can change the game configuration. We can make builds that have different game configuration. So for instance, whenever we're giving out a build to the press, we only include a subset of tracks, for instance. And when we're doing a full build, we have all of the tracks in them. But we could also we could change difficulty of tracks, we could change whatever parameter, and make different builds with different parameters. And that's how it looks like in the editor. So we have our build manager. On the top, you see we have a few extra script defines and so on that we can set in the editor. And then we have the global settings and the personalization data. And a few options, so you can shut down after a build, you can make a dry run, and so on. And on the right-hand side, you see the global settings. Game name, version, a major version, minor version, build number, and so on, because it also helps us so when you're doing incremental builds, your hard disk will fill up with many builds, and then when you have an easy way to version them, it makes things a bit more manageable. And then additional platform settings. Then we have the list of builds that we want to create. So on the very left side, you see it's just a list, and in this list, we can add just items. And in this case, it is, for instance, a clean Windows release and a press release and a PC debugging build. And I can just, for instance, I can add a build for Matthias. I can add a build for competitions, for instance. So usually as indies, you participate in many competitions, and at some point you have to update all your competition builds. So I can just use a list for competition builds, and it choose out 5 different competition builds for each competition. In the middle, we have a specific personalization kind of data entry, where we can set the name, we can set the watermark, we can set the languages that are supported. We have localization paths that you can start the game with different localizations, and so on. And it also has the build type and the track list. So with the build type, let's see. Oh, the build type is on the right, sorry. So build type is then you can just select PC, PlayStation, Xbox, and so on, and have a few settings. Is it a debug build? Do you want to have script defined, and so on? It's kind of all those settings. And then we have the track list. This is where it ties into kind of the game configuration. So for game data, we also are trying to be as much data-driven as possible. And for each track, on the right side, you see kind of configuration for the track. It's kind of the scene name, the images, the difficulty, parameter curves, and so on. So we can really make different builds with different configurations and really tie into game configuration. Another thing that's very important, and it's very easy to implement, and it doesn't look like much, is checks. So whenever you start a build, we have a few prompts showing up. For instance, do you have enough disk space? Because it often happened that, well, you're starting, I don't know, 10 builds, you go home after your working day, and the next day you find out, well, it only created two builds because you ran out of disk space. So just having a reminder that you probably want to check the disk space, and also tells you how many configurations are built. Did you update the version number? It's a minor thing, but when you're creating builds with wrong version numbers, it can be very, very painful. And also a small one, so we added a dry run option just to try things, and if you have the flag on unintentionally, you're not getting any builds because it's only a dry run, and it tries to tell you that. So going a bit into more details, so how it actually works for each build. The make build is kind of the second last part. That would be whenever you press build in Unity, but there's so much that we do before that. So the first thing is we set up script defines, debugging, logging, and so on. And we also generate a C# config file, because that was the easiest way for us to transfer over all the build config into the final game, just to create a C# file that we can then use in the game. We use C# file generation at some other points, and it works okay. It has its drawbacks as well, but it's fairly easy to do. Then we might have to patch a few assets. On PC, we use Google Analytics, or for development, we use Google Analytics. And just to get the version number into Google Analytics, we take the asset, we patch in the version number, and save the asset again before we're doing the build. We create a new output folder to make everything neatly organized. And the most recent thing that we added was to dump the config and the git hash to disk. Because when you're making 10 builds, it's always guesswork. Well, in this build, what were the settings that went into that build? Was it a development build? How many languages are included? What are actually the tracks that are included? What settings did I use? So by just dumping all the config, you can afterwards, when you take a look at the build, see, OK, it was these settings and these platform settings and so on. makes your life much easier, and it's just a few lines of code. And the second thing that we added was a git hash. So it just dumps a file to your disk that has the current git hash in it. So whenever you take a look at a build, you know exactly what was the parent version in a repository. So if you're really trying to hunt down bugs in a build, you really know exactly where that build came from. After we did all that, we switched the platform if needed, so we can make PC build, we can make PlayStation build, Xbox build, switch in between. So in one go, I can many different builds. And finally, tell Unity to make the build. And then we do. We also post the build progress to Slack. So we have our own team Slack, and with Slack, it's very easy. You just have to post to a URL, and it will show up in your Slack. So in Slack, we can easily track when a build is done, if it failed, and so on. So I can, in the evening, start a build overnight, and then when I'm home, I can just check on Slack, did it run through, how many builds did it create, what was it working on, and so on. That's quite convenient. Here's briefly the C# config file, and it's pretty much a one-to-one translation of the configuration. So we just dump everything in there that we can then use in code, for instance, the version number, or should we show a watermark or not? And then at runtime, we just look it up there. I assume there are better ways, so we could also probably use scriptable objects, but that was kind of the first thing that we had working, and yeah, it stayed. Whenever stuff is working, usually, yeah, you don't change that much. OK, there's, of course, a couple of issues with that. We have a shitload number of files. So kind of for all people that we ever created builds for, we have different files. For all build types, we have different files. There's so many files. So we're pretty much doing a database, but manually in files by hand, and it can be a pain. It is still somehow manageable, but it's not ideal. Whenever we do builds, we change the Unity configuration. So we change the project settings, we change the build settings, and so on. And these are all saved in Unity. So whenever we do a build, it, of course, changes these files that then show up in Git. And then somebody checks in those files, and it creates conflicts, and so on. So it's not very ideal. It would be perfect to have an option in Unity to just say, OK, take these temp settings and create a build, and please leave all the files untouched and the settings files and so on. Please leave them as they are and just create a build with that. But yeah, so we always have kind of a few files sitting on a Git repository that are changed, but that we don't really care about because they have been kind of auto-generated. Yeah, and another issue that we had, it's not directly connected to the build pipeline, but we wanted to have it make it repeatable and robust. But we had issues where the asset database has been kind of corrupted in between crashes and between switching platforms. So making a build on 2 different machines with the same settings produced different builds. And that can happen, and usually re-import of assets helps, but that's still an issue, and that's also unresolved in our build pipeline. OK, just briefly, a few smaller tools that we have. So we're not only doing kind of the large tools and pipelines and so on. We also have kind of a few stupid, very simple tools. First one is just a track selection, because it's just tedious to go into the project to find all your scene files and so on. We just wrote a simple script. Whenever you press the button, it just loads that scene file. It's just hard-coded. We just hard-coded in the path to the scene file. Just press the button, and it loads the scene. It's very easy. In the middle, you have pretty much the same thing, just selecting prefabs or finding a live object when you're in play mode, so you don't have to go through the hierarchy. You just press a button, and you have the player object, for instance. And on the right side, it's pretty much the easiest script. It's just a placeholder of editor objects, and you can just put in an object, and whenever you double-click on it, it is automatically selected. So it's pretty much just a selection tool. It's very handy. it's really dumb. It doesn't do anything. It's just a GUI element that you can put stuff into and use. OK, that's kind of the Unity part. And here's the bonus stage. We use a couple of things that go beyond the Unity editor. And this can also be quite useful. So the project that we're using is called Spacebark. It was something that I created some years ago. It's browser-based, it's socket-based, so it's I'll show it to you. That's what it looks like. So we use it, for instance, for graphing in Unity and plotting data. So it can be very complicated, it can be very simple. So you could use, for instance, the network just to break out of Unity to create your own tools. We used it for visualizations, for instance, to have a histogram of lap times that we kind of just pushed out of the editor into the browser to visualize them to see how they work. So that's also what we do. It's not only in Unity. Unity is very practical and handy, but you can also easily get out of Unity and connect different things to it. OK, coming to the end. So what we learned, it can take a lot of time to write the tools, especially the Maya import export pipeline took quite a lot of time. But I guess it paid off in the end. And it's always the tools that shape the final product. So we could have realized the project without the tools, but it probably would look differently in the end. But just having, for instance, the import-export pipeline, it really allowed us to move quickly between Maya and Unity, change stuff around quickly, and it really changes how you work. To be honest, we never really understood all of the editor GUI APIs because there are so many. And thus, our GUIs are very, very simple. And I guess that's also one of the things that we want to change in the future going forward, to have a bit nicer GUI, make it a bit more structured. And as we learn, we improve stuff. It's really editor scripting and GUI scripting in Unity is something that you can really just add onto all the time and just improve it, because it's, from a systemic perspective, it's not that complex usually a script, and you can just do little improvements here and there. Whenever you find out something new, you can add it. Another way that we'd like to find out was to, as I said, with the issues with the build, to separate kind of the local user settings from the project config, and to somehow decouple them, so whenever you do build it doesn't change everything. And same thing with the source files that we have, like the build constant thing. Everything is auto-generated and changed all the time. Can be quite annoying when you have it in your Git repository. Yeah, that's it. I hope it was interesting for you. Please get in touch. If you have any questions about what we talked about here today, either ask now or find us afterwards, tweet to us, send us an email. Yeah, thank you very much. Do you have any questions? Sorry?
For instance, you said that you use Git for Unity repository, right? And as I understand, 3D guys also use this Git repository to commit some stuff. How do you handle this? Because for them it will be sometimes complicated to use.
I guess it works out pretty good. So they haven't used Git before, so it was a learning curve, of course, involved. But surprisingly, we didn't run into that many issues. And it's also a team of 4. It's just 2 artists. They sit across each other. So we never really ran into large Git and merge conflicts. So, but I guess when you're on a larger team, you probably might look into more sophisticated solutions.
Do you use some build servers, as I understand, Jenkins or something like this?
Jenkins? Do we use Jenkins?
Right?
No. Yeah. So we don't have a build server. We don't use Jenkins. It's all locally, because It seemed to be sufficient for our needs, and maintaining a build server, yeah, that's...
But it would be super easy to integrate into Jenkins. If you wanted to do it, it would just adding, since you can start all the scripts through a command line with Unity, you just have to create the right line, and that's it. So it would be super easy to integrate in Jenkins. Yes.
Okay. No question?
Hi. I was also sort of wondering about the build process. You have a lot of editor tools inside the editor, which is really useful. I can see that. I was wondering if you also had some tools between the editor and actually publishing, such as automatically uploading it to, for instance, Jenkins, or deploying it on the build targets, such as mobile or console or PCs.
There's nothing too sophisticated that we have. So publishing is pretty much all done by hand, going through all the portals and so on, and doing the uploads, because kind of they have all the pipelines and stuff. So, and since we're new to the game, it's also for us trying to figure out how it all works. So we didn't really have the need to automate anything with tools. The one thing that we have is to distribute our own builds to press and so on. We have an Amazon Web Services S3 bucket. And we have kind of our own little system where we can create folders with a kind of a random prefix that we can then hand out to press. It's kind of a very cheap and easy Dropbox replacement. So when I send a link to you, it looks pretty much like a Dropbox link, but it's our own infrastructure. So
okay, thank you.
Okay,
yeah.
If there are no more questions, we'll be besides the stage or just find out afterwards. Thank you very much.
Okay, thank you.